Your teacher has a problem and needs your input. She has to give one math award this year to a deserving student, but she can't make a decision. Here are the test grades for her two best students. Bryce made a 90, 90, 80, 100, 99, 81, 98, 82. Brianna's test scores were 90, 90, 91, 89, 91, 89, 90, 90. Write down which of the two students should get the math award and discuss why they should be the one to receive it. Okay, what do you think? Why?
I just think his grades were better.
Okay, so he has the top score. Anybody think Brianna should get it?
Yes.
Okay, why? Okay. Right. She's more consistent. She did good consistently where he had some bad grades. Okay? Well, when you're talking about the top award for the class, I mean. Okay. Now, what else could we do to kind of figure out who's better? The mean. Okay, so this is what I want you to do. I want these first two rows closest to me to calculate the mean for Bryce. Everybody else calculate the mean for Brianna. Don't yell it out, just do it on your calculator. What was the average test score for Bryce? A 90. What was it for Brianna? So that doesn't really help us. Finding the average doesn't really help us. So we're going to find something called the standard deviation. Okay. It's kind of a lengthy process, so you're going to have to pay attention. Now, see how this is a table for Bryce? All of this is about Bryce? Well, there was originally another table for Brianna, and somehow it didn't get copied in the packet. So what I've done is I've just split it. Okay? In each column, I put a big line, and that way I can put Bryce's data on the left side of the column. Brianna's data will go on the right side of each column. So you want to go ahead and draw in your lines and put Bree for Brianna on the right side, so we know that all the data is going in the same table. Bryce is on the left, Brianna's on the right. Brianna is how you say it.
It's Brianna.
Okay, now what are these numbers right here? What are these numbers? Those are Bryce's test scores, so what do we need to put right here? Brianna's test scores, which are here, let me remind you that I'm videoing. Okay? Now, after that, you're going to find the deviation, like how far each of their scores were from their average score. So to do that, you just take each test and minus the mean from it. Well, what was Bryce's mean? So what's 90 minus 90? And there's two of those. What's 80 minus 90? Negative 10. What's 100 minus 90? Positive 10. What's 99 minus 90? 9. What's 81 minus 90? Negative 9. What's 98 minus 90? 8. And what's 82 minus 90? Negative 8.
Are you sure the third one's
All you're doing is you're taking each test score and subtracting the mean from it.
The third one, negative
80 minus 90 is negative 10.
Oh.
Okay, that's all you're doing is subtracting the mean from all 8 of his test scores. Okay, and that's how we got these values. No, the mean was 90. Anna, her test scores are right here in pink. What was her mean score? A 90 as well. So 90 minus 90 is 0. There's another 90, so that's another 0. 91 minus 90. 1. 89 minus 90. 91 minus 90. 89 minus 90. 90 minus 90. And 90 minus 90. Okay, those are the deviations from the mean. Now, this next column. What looks different about this and this? Absolute value bar. So what does that mean we're going to do to each of these numbers? Right. Well, you make them positive, right? Doesn't the absolute value of a number always become positive? So all you're going to do is rewrite this list, but all of those negatives are going to turn positive. Right, this is Bryce's. And then we'll do the same thing for Brianna. So hers will end up becoming 0, 0, positive 1, positive 1, positive 1, positive 1, 0, 0. Now the next thing that we're going to do is take the deviation and square it. So starting with Bryce's list, we're going to square all these numbers. What is 0 squared? 0. 0 squared. 0. 10 squared. And there's 2 of those. 9 squared. There's 2 of those. 8 squared. And there's 2 of those. So those are the deviations squared. Now we'll do that for Brianna's data. So what will you get? The same thing, because when you square 0, don't you get 0? And when you square 1, don't you get back a 1? Okay, so now that we have all that data filled in, we're going to find the mean deviation for Bryce and the mean deviation for Brianna. We're going to find the variance for Bryce and the variance for Brianna. And we're going to find the standard deviation for Bryce and the standard deviation for Brianna. Okay, to find the mean deviation, here's the formula. Now, this symbol right here means take the sum. What does the sum mean? Add it up. And we're adding up all of the positive deviations, which are in this list, right? Sigma. Yeah. So we add up all the positive deviations. Well, here's the positive deviations for Bryce. Add those up. 0 plus 0 plus 10 plus 10 plus 9 plus 9 plus 8 plus 8. $54, right? But then that's not all they tell us to do. They tell us to divide by n. What do you think n is? All the numbers. How many numbers were there? How many test scores? 8. So you divide that by 8. What's 54 divided by 8? Right. So Bryce's mean deviation is 6.75. That means his average test score was 6.75 points from the mean. Like if you took all of his test scores and found the difference from the mean and then you average those numbers, you get 6.75. Okay? Now let's do it for Brianna. Her positive deviations are right here. What do you get when you add those numbers up? 4. How many numbers are there? 8. What's 4 divided by 8? 0.5 or 1/2. So her mean deviation is 0.5. Okay, next we find the variance for Bryce. To find the variance, you're adding up the deviations once they've been squared. Well, isn't that this column? Okay, so add up those numbers. No, that's summation. That means add them up. Okay, it's 490 and we divided by 8 because weren't there 8 test scores? So what is Bryce's variance? Okay, now let's do Brianna's variance. Okay, that means we sum her deviations that have been squared. So that's this final list over here. 4 divided by 8 again. So her variance and her mean deviation are the same. Now, to find the standard deviation, all you're going to do is what? Look at this formula. What's the only difference? Square root it. So you just square root the what? The variance, 61.25. What is the square root of 61.25? Okay, now let's find Brianna's standard deviation. What do? Square root of 0.5, which is 0.71. When we added up all these numbers, the deviations squared. Okay, now, see how Brianna's standard deviation is much closer to 0 than Bryce's? That proves that she was more consistent. Now, with a data set of 8 items, it was pretty easy to just look at it and see that she was the more consistent. But say that her teacher wanted to include every single score in the gradebook, all the daily, all the quizzes, all the tests. Do you think it would have been easier just to look and see who was more consistent in their grades if you're looking at like 50 grades opposed to 8? No. So that's where standard deviation would come in. The closer you are to 0, the more consistent. So like if you had a data set like this, what would the standard deviation be? 0. They're all the same number. Nothing deviates. Think about it. What would the mean of those numbers be? 9, right? So have any of those data items deviated from the mean of 9? So the standard deviation would be 0. Okay, because isn't that as consistent as you can get? That's why the standard deviation is 0. Okay, now, when it comes to deciding who gets the award, it's really more complicated than just looking at it numerically, because it's really about the teacher and what their preference is. Do they prefer consistency, or are they looking for the one who made the top scores, which is really hard to say because, yeah, Bryce did have a few really great grades, but then he had a few that were way lower than hers. So it really is just the opinion of the teacher, and of course other factors would come into play too, like behavior, stuff like that. I would probably go with Brianna. I like consistency. Okay, now turn to the next page. Turn to the next page. Now the next thing I want you to do is, by yourself, don't yell it out loud once you get it, calculate the mean of this data. Okay, so take about 1 minute, calculate the mean of this data. What did all of those numbers add up to? 112. And how many of them are there? 30. So what's the mean? 3.73. Okay, now, Cody and Bernice both got the correct answer, but it took Bernice a lot longer. Bernice added all the values and divided by 30, kind of like you just did. Cody told her there was a quicker way to do it. Can you figure out how Cody did it? Quicker.
Cody, how'd you do it?
Anybody? Did anybody do it quicker than... Right. If there's 2s, 3s, 4s, and 5s, instead of typing in 2 plus 2 plus 2 plus 2 plus 2, couldn't you just do 2 times 5, and that's a lot quicker? And 3 times 9, and 4 times 5, and 5 times 11, wouldn't that be a lot less typing? And it would still add up to 112, and then you would divide by 30 and still get the same mean. It's just a lot less typing. Because I wanted to see if you could figure it out yourself. Because we're taking the mean, and so you have to divide by the number of terms. There's 30 numbers in that data set. Okay, the teacher then asked the students to calculate the standard deviation of the data by hand. So, remember, step 1 for calculating the standard deviation, didn't we have to subtract the mean, which we just found to be that, from each of the numbers? Okay, what is 2 minus 3.73? Negative 1.73. But aren't there 5 too? So aren't we going to end up with 5 of those? So multiply by 5. Then, what's 3 minus 3.73? Negative 0.73. But aren't there 9 of those? So we would have multiplied it by 9. And then, what's 4 minus 3.73? 0.27, but aren't there 5 of those? And then 5 minus 3.73. 1.27, but aren't there 11 of those? Then after that, once we found the deviations, all the deviations, what did we do to all of them? Well, before we added them, did we do the absolute value, which just turned all of them positive? And then what did you do to them? Squared them. And then after you squared them, didn't you add them all up, divide by how many there are? That was the variance, and you took the variance and square rooted it to find the standard deviation, which is a lot of work, right? So I'm about to show you how to do it in the calculator. Okay, here we go.
Wait a minute. Wait. Whoa.
Okay, so The reason we're not finishing that is because I'm about to show you how to do it in the calculator. You're never going to be expected to do that by hand in this class anyway. Okay? So, here we go. How do I put a list in the calculator? First, let's do something. Everybody hit second plus sign 712. Reset your calculator. That way nothing's in there from last period. Second plus sign 712. Okay, now how do I put a list in? Stat, edit, and then we have 2s, 3s, 4s, and 5s. Now, if I wanted to keep everything in L1, I would have just typed in 2, 2, 2, 2, 2.
Clear one time.
That's why you should have done second plus sign 712. Okay, but listen to what I'm saying. Aren't there technically 5 2s? So really, there should be 5 2s listed right here instead of 1. But to save time, I'm going to do what we call a frequency list. Out beside the 2, I'm going to put a 5. That way the calculator knows there's really 5 2s. And so beside the 3, I'm going to put a 9, so that the calculator knows that this list really had 9 3s. And beside the 4, I'm going to put a 5, and beside the 5, I'm going to put 11. Does everybody understand what I'm doing? Now that the data's in there, okay, it's not all in L1, but it's all the same list. I'm going to hit stats, calc, because this time I'm ready to do something with it. It's still one variable because it was still all one list of data. Okay, but look, my list was in L1, but in L1, was that all 30 numbers? No, so we have to let the calculator know that we put the frequency of the numbers in L2. Well, look down here above the 2. Don't you see L2? So what do we need to press to get it? Second, and then 2. And now that the calculator knows that your numbers are in L1, but the frequency of them is in L2, now hit calculate. Mean, 3.73. Isn't that what we got for the mean when we did it by hand? This means the sum of x. When you added up all of the terms, did they add up to 112? This is the sum of the x's squared. This is what we're looking for. This little symbol is the standard deviation, 1.12. And isn't that a lot easier to do in the calculator than doing all those steps? Because look, I'll quickly finish out what we were doing by hand to show you that it's 1.1. We're almost done. Well, I'm almost done with the teaching part. Okay, question number 1. They want us to find the mean, median, variance, standard deviation, and IQR. Now, for number 1, is this a list that we're going to need to use a frequency list for? No, because you have 2 8s, but is there any point to creating a frequency list just for 2 8s? No, frequency lists are only helpful when there's a lot of repeating numbers. So, remind me, how do I type in that list? Stat, edit. Okay, now, if you're wanting to know how to clear your previous data quickly, everybody look at the board. Go up, highlight L2, hit clear. When you go back down, it's gone. Go up, highlight L1, hit clear. When you go back down, it's gone. If you accidentally hit delete, it will delete out the whole column and L1 will be gone. It'll start with L2. In that case, you would need to reset your calculator by doing second plus 712. And you go up, hit clear. When you go back down, it'll be empty. Okay, so let's put in this data. 6, enter. 22, enter. 4, enter. 15, 14, 8, and 8. Okay, there's no need for a frequency list because we didn't have enough repeaters. Now you go back and hit stat, calc. One variable. We didn't have a frequency list, so you need to hit delete and get rid of that L2. And then calculate, and there's all your answers. So what's the mean? 11. Okay, median. The median's not on the screen, so we got to scroll down. What's the median? Yes. What's the median? 8. The calculator doesn't give you the variance. We'll have to do that in a minute. What's the standard deviation? 5.83. And then IQR. How do you calculate IQR? Interquartile range. Remember, range is the highest number minus the lowest. Interquartile range is Q3 minus Q1. Well, what is Q3? 15. What is Q1? So what's 15 minus 6? 9. Okay, now, a while ago when we were doing the standard deviation by hand, once we found the variance, what did we do to it to find the standard deviation? Square rooted it. So if you want to go backwards and find the variance, what do you need to do to the standard deviation? Square it. So you would do 5.83 squared, and that would give you your variance. 33.99. I just looked at my Q3 in the calculator and my Q1 and subtracted them. Okay, now turn to the next page. I got one more to do with you. Okay, number 5. The frequency table shows quiz scores from Ms. Fehrenbach's class. Find the following for the data set. Okay, this time, this is a whole class. So instead of writing out 50, 55, 55, 60, 60, 60, 60, 65, 65, 65, that would be a lot of typing in. They created a frequency table to show that there were 2 55s and 4 60s and 3 65s. So let's go and type in that table. What do I press first? Stat, edit, clear out the data from the previous problem. Okay, then enter in your scores. No. You just got to make sure if you do them out of order that your frequency matches. Like you have to have a 2 by the 55 and a 3 by the 65. Okay, now over here, how many kids scored a 50? 1. How many kids scored a 55? 2. How many kids scored a 60? 4. And then 3. And then 5. 6. 3. 2. 190, 195, and 0, 100. So honestly, if you left out that 100 0 from your table, it won't be the same data as somebody who puts it there. Because really, there's not a 100 there. Okay, so now that the data's in, what do I press? Stat, calc, one variable. It's still all just data from a test. Okay, and then this time though, we do a frequency list in L2. So second 2, we'll pull up L2, then calculate, and there's all your answers. So what's the mean? Okay, the range, how do you calculate range? Highest minus lowest. What is the highest score? 95. What's the lowest? Nobody made a 100 though, so that's kind of tricky. Nobody made that, so really you could have ignored that from the beginning and not even put it in the calculator. Okay, so the highest was a 95, the lowest was a 50, so that gives you a range of, 95 and 50, so 45. Now, mode is very simple to find once you have a frequency table, because what would you look for? The highest frequency, and that lets you know there were 6 75s, nothing else had that many. Now, what's the standard deviation? 10.72. What's the median of this data? 70. And then how do you find variance? You just square the standard deviation. Okay, what do you get when you square 10.72? 114 point what? 91. Okay, so your classwork, and whatever you don't finish, you've got to finish on your own time, is this number 6 and then the 3 problems on the previous page.